Alright guys, we got a review for Q12 now. So we'll begin with the conceptual. First thing is the difference between a vector and scalar. Remember that a vector has magnitude plus direction, whereas a scalar is only magnitude. So very simplistic stuff here. 10 quantities and units for the first semester include vector scalar quantity. So this takes a little bit of work. Let's go through the fundamental and derived again. We have kilogram, meter, and second. So those are the fundamental. So we have mass, length, and time. And then if we look at these, mass is a scalar, time is a scalar. But length, however, if we use the word displacement, as soon as we use the word displacement, now it's a vector. If we just consider length, we'll call it a scalar. Length or distance, same thing. Now we have all our derived quantities like density. So density, that is a scalar. Area, scalar. Volume, scalar. Some of your other ones like velocity. Remember, velocity has another name, speed. Speed is the scalar of velocity, which is a vector. We have acceleration. Acceleration is a vector. We have momentum. Momentum is a vector. And we have force. And force is also a vector. So let's count them up. We had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are our 10 quantities, and whether or not they're vectors or scalars. Alright, so we continue on. We got that done. That was a beast. So here we go. Velocity and acceleration. List the three types of velocity and explain how they relate to your car. So the three types are constant. Remember that constant is if you're in your car and you're going on a straight road and you have your cruise control set. We have average. Average is nothing more than the total distance over the total time. So, for example, if we traveled 200 miles in 2 hours, our average speed would be 100 miles per hour. So very simplistic stuff again. And the last one is instantaneous. Instantaneous is looking at your speedometer for a fraction of a second. Also, instantaneous velocity relates to a position time graph. So if we have a position time graph and you find the slope at one point on that position time graph, that is your instantaneous speed. Alright, why is acceleration the rate of a rate? Acceleration is actually the only rate of a rate you'll ever study. It's a meter per second per second. So it's the rate of change of velocity. So this is a rate right here, and then this makes it the rate of a rate. And you know, don't be confused. It doesn't always have to be seconds squared. You could have meters per hour per day, and that would still be considered acceleration. What are the three accelerators in your car? Remember, to accelerate, you just need to change your velocity. Velocity is a vector, so it has magnitude and direction. So our three accelerators would be anything that either changes the magnitude or changes the direction. The obvious one is your gas pedal. That increases your magnitude. But don't forget, you also have your brake pedal, which decreases your magnitude. And the one everybody forgets, your steering wheel is also an accelerator, as it changes your direction. So if you change your direction, or you change your magnitude, you've technically accelerated. Free fall. What does it have to be free fall? True free fall. There are three conditions which must be met. One, no air friction. So it's like the tube I showed you in class where we suck all the air out and the feather and the penny fall at the same rate. Two, we have how it starts. It starts at rest, which means that the V naught and D naught are 0. And we also have gravity is the only thing affecting how it falls, so that's 9.8 meters per second squared. Anywhere on Earth we get the same gravity constant. How far does it fall in a second? We use the free fall equation, d equals 1/2 gt squared. We put 1 in for t, and we get 4.9 meters. How fast? V equals gt, so we take 9.8 times 1, and we get 9.8 meters per second. What's the acceleration after 1 second? It's constant. It's always 9.8 meters per second squared. Whether we said 5 seconds, 10 seconds, 3 seconds, it's always 9.8 on the planet Earth. Graphing. Make a position time, velocity time, and acceleration time graph for a person jumping up, landing at the exact same spot where he or she took off from. Here's my position time for the jumping lab. Here's my velocity time for the jumping lab. Couple key things. Notice it's a straight line. The time it took to get to the x-axis is the same it takes to get to the y-min. Same. And then we have acceleration time graph. Notice that in the acceleration time graph we're sitting at a negative 9.8. Stays constant on the planet Earth. There's our graphing. We're finally to setting up the problem. Alright, so in this problem, we go through and do all our steps. So we've got a cliff, got a man on the cliff, throw the rock up, throws it up at 15 meters per second. It goes up, so we have our motion diagram, dots get closer, follow the exact same path on the way down, and then they speed up. Eventually, this object crashes into the ground. The dots show acceleration, which is gravity, 9.8 meters per second squared, down. So we have to figure out where we want to put our 0 at. We also need to realize that we are 17 meters off the ground. So where do we put our 0? In this problem, the best place to put the 0 is at the ground. And you should make up positive. Although it's your free choice, you could do it at the apex, but the problem is we don't know how high the apex actually is. You could also put it as hand, but that's going to create negative and positive distances, and you just don't want to get into that. So what we want to do is put the 0 at the ground with up being positive. Now we have our knowns. So we know that it starts at 17 meter. We also know that it starts with an initial velocity of 15, and we know that acceleration is equal to gravity. And because it's going against this arrow, it's negative 9.8 meters per second squared. So those are our knowns. We also know that the velocity at the apex is 0 meters per second. Our unknowns, or the things we'd like to find, are listed in the problem. It says, explain what equations you would use to solve for the velocity the instant before it hits the ground. So we want to know the velocity when the d equals 0 meters. It also wants to know what equations would you solve for the maximum elevation. So that's d, distance, when the velocity is 0 meters per second. So those are my unknowns. Now when I do this problem, I want to pick my magic physics formulas. And so we can use our formula sheet. And the formula sheet will help you decide which ones to use. At a minimum, you're required to do the 1-step. If you want to go for the 2-step, you can. Or you can go for both and go for the extra credit. In this quiz, you're only required to do 1, though. So let's look at V at 0 meters. So V and D is what we're working with. V and D. So what's the 1-step for V and D? Well, that's number 4. Number 4 is V squared equals V naught squared plus 2A D minus D naught. Put in all our variables. We want to control it with D. So I box up D and I underline V. And that's all I had to do. I could also do a 3-1 combination to get v. So I could also do a 2-step and do a 3 followed by a 1. If I do a 3-1, it's d equals d naught plus v naught t plus 1/2 at squared. And what I want to do is I want to box up d, and I want to get t. Notice that I'll have 2 t's. I want to take the positive root. And then what I do is I bring that t down into number 1, v equals v naught plus at. When I bring it down, I guess I'd bring it there, right? As I bring it down, I can then solve for v. So notice I had the same thing as before. I just had to use 2 equations to do it, using the intermediate of time to get there. For the other one, where I solve for the distance when the velocity is 0, I can do that as a 1-step with number 4 as well. So now I rewrite number 4, v equals v naught squared plus 2a d minus d naught. And I want to, this time around, I want to solve for the distance. So I underline the distance and I control it with the velocity. So that's the 1-step. And then I also have the 2-step. So the 2-step, I just switch it around. I do a 1-3. So v equals v naught plus at is how I start it. I'm going to use time as my intermediate again. I'm going to control it with v. I'm going to get a t. I'll bring the t into number 3. d equals d naught plus v naught t plus 1/2 at squared. And I'll put in t here and here, and then I can solve for d. And that's as far as I expect you to take it for the quiz. If you want to go for extra credit, then you would move on and you would actually put numbers in and solve for it.